Welcome back!
All right, welcome back, everybody. We are ready to talk a little bit more about the law of signs.
Law of signs? Did we already do that?
We did that, but weird things can happen with the law of signs.
Crap.
Okay, so here's the weird things that can happen. It's called the ambiguous case, and we're going to talk about why that is. We're going to talk about whether or not we can get a triangle and how many triangles we can get, and if we can get 2 triangles, we got to solve for both of them. All right, take a look at the exploration. Oh, remember angle, angle, side, angle, side, angle, side, angle, side, 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 side. These are all theorems from geometry because they always created 2 congruent triangles. So the reason we didn't use side, side angle is because it makes ambiguousness. Is that a word? All right, so let's take these pieces. We got 4.5 centimeters, and if you want to measure on your paper, you'll see that it is actually 4.5 centimeters. We've got a 30-degree angle. I didn't bring a protractor, but this is 30 degrees over here. And this is our 4.5 centimeters here. And what we want to do is try to create a triangle with a length of 3 centimeters. So 3 centimeters goes from there to there. So that's the only piece I'm allowed to use in creating my triangle. So if we draw it over here, and I start, and I make sure that my ruler lines up at 3 centimeters. Here's my 3 centimeters. I could draw it right here. This could be my side C, and this could be my 3 centimeters. But did anyone draw it differently? Because you could have. Where else could I put the 3 centimeters and still create a triangle? Remember, this side is dashed because we don't actually know how long this side is. So what if I put the 3 centimeters this way? Here's the end of my ruler. Here's my 3 centimeters, and that could line up right here. This is also 3 centimeters. Since I don't know the bottom of this triangle, I don't know if C is actually on the right side or the left side. Creates 2 unique triangles. One is very obtuse and one is acute. Okay. All right. So we should have ended up with a picture that looks like this, and you can see we have our 2 unique triangles here. One is very obtuse.
Fact.
And one is acute, and angle C is the difference. So now we're going to get into why
So you're
that
telling me
happens.
there could be not just 2 triangles, but there could be 2 answers for angle C.
Yes?
There could be 2 lengths for, what, side B?
Yes, the bottom.
So B could be short or B could be really long?
Yes.
Oh.
And angle B could be bigger or smaller based on how big angle C is.
And we're going to try to do this all without a picture, really, or without constructing it like you did.
Right, without a ruler, without a protractor.
All right.
We're going to explain to you how it's working. All right. So there is a spot on your notes here for talking about no triangles, 1 triangle, 2 triangles. More on that in a minute. Instead, let's get into the examples. Let's try it.
Okay.
Okay, you're on.
All right, I'll draw. You talk.
Okay, so the first thing we're going to do is set up this triangle. We're going to draw angle 56, sort of on the lower left corner. Remember that across from angle 56, angle the W, where it's going to be side W. So go ahead and finish out your triangle.
So I'm just pretty much going to make a triangle, even though I don't even know if one exists. I'm just going to draw it so I have some places to make a reference.
Yes, and to make, we're going to label the sides.
So here's little W is on this side. We'll call that 30.
Correct. Now, either of the other 2 sides could be little x. If we orient it like we did our exploration, then the other leg of the triangle and not the bottom of the triangle is going to be the x26.
So we want capital X here?
Yes, we do.
And again, it doesn't matter, but we're just
doesn't.
going to try to set it up the way we did before.
And we're going to try to be consistent for
So
you.
we were given an angle, side, side.
Yes, we were. Which stands for angle, side, side. Okay, now we probably need to name the other vertex of our triangle. So this is W and X. Let's call it Y.
Alrighty.
Okay, so to figure out how many triangles there's going to be, let's go ahead and solve it. We were pretty good at law signs.
Let's just do it.
Okay.
So we have opposite side to sine of 56, so we go sine of 56 degrees over 30.
And that's going to equal the sine of x over 26. And the reason I picked the x is because I know the side 26. All right, we're going to do magic algebra. You've already done that.
Magic.
And you're going to get that the sine of x is equal to 26 sine 56.
In other words, we're assuming you know how to do this. And in fact, if you just want to sit back and watch and then write down later what you think was important out of all this, you don't necessarily have to write all this down right this minute. Okay?
Right.
So just feel free to just watch and scribble down whatever it takes for you to remember this process.
That sounds great. And you've already solved this, so just take a look. So that's going to give us angle x, which is going to be approximately, we don't need all that. They know how to do the algebra.
It's all that stuff, right?
Yep. Angle x is going to be approximately 45.931 degrees.
And in reality, you should be storing all those decimal places on your calculator somewhere so that you don't use this number later in the problem.
And you don't round.
Yes, we don't want to round till we're done. And we're not done until we get all the angles. So
Okay. So the next thing you would find, and this is just like last night's homework, you would find angle y. To find angle y, you're going to say 180 minus the two angles you already know. So y is going to equal 180 minus the 56 and minus the capital X. Okay? When you do that, I'll do the math for you, you're going to get 78.069. Again, you would use law of sines, and you would find, what's the only thing left?
we need to find little y right here.
And we would set it up with the sine. I would go back to the sine of 56 over 30 because we already know that.
It doesn't use any rounded off numbers. So we're going to go sine of 56 over 30, and it's getting messy down there.
It is. Equals the sine of the y that we know over the y. Long story short, there's a whole bunch of algebra. And
I'm
we
going
get
over here.
little y. I don't think we have to write that part down.
Okay, I'm doing it anyway.
Okay. Sine of 56.
Well, sine of 56 over 30. It doesn't look any better up here because I'm writing it. Was a sine of this y value that we now know over little y.
And when we solve that, we get little y equals 35.405.
Now, the question did not ask you to actually solve this triangle.
No.
It said how many are there.
Well, obviously there's one.
So we did this to just kind of show them that there was one triangle and we now have found it. But
Correct.
Is there another one?
Is there another one? So, let me have a marker. New color. If there was another one, then that means,
Let's just do it in page.
okay, new page.
I need your head up.
If there was another one, we need to always go back to the first angle we found. And the first angle we found was angle X. Okay? And X ended up being, I forgot already, 45.931. So, if it really works,
So let's draw this the same way we had the original picture that we had
this
with
was
the
the
little expression.
56.
56 was there. We were given, well, you found 45.931, and we were given that other side was 30.
This one.
This one, yeah.
Okay, so if there is another triangle, then that means the 30 would flip this way. That's a really
Correct.
scientific word. And if this is 30, then this right side of the triangle is actually an isosceles triangle by itself.
Just that little bitty picture there.
That little red picture right there is an isosceles triangle, which means if the base angle over here is 45.931, then the base angle over there is 45.931.
Same angle. So, but that's not part of the second triangle that I'm looking for, is it?
No, it's not, because the second triangle you're looking for is the blue triangle. So my question is, what's the relationship between this blue angle and the red angle that's 45.931?
Well, they make a straight line, so it's just 180 minus 45.931.
Cool.
Whatever it was.
It was 40.
So basically, I solved for the first angle using law of sines, and I realized once I did that, I know there was one triangle available. But then you're telling me that if another one's going to exist, I can just subtract that from 180?
Yes.
And get the possible second triangle's angle?
Yes.
Is that right?
So the first possibility for x would be 45.931. The second possibility for x would be this obtuse angle of 134.069.
Okay.
Now let's think about this. It still has to make a triangle.
Right.
So if the new x is 134.069 and we go to find the new y value, which is up here,
Well, we were given 56 to begin with, so the last time we wanted to
Right.
find y, we went 180 minus 56 minus x, but
right, but that's already more than 180.
that's not going to work. That's 190 something, isn't it?
Can I have a triangle with three angles that add up to 190?
No.
That
In
doesn't
fact,
work.
I'm going to do real quick one thing here. You know, if we stick with the same thing last time, we went 180 minus 56 and then minus our value of x.
Correct.
If we did that again, we end up with like a negative 10 point something degrees.
And that's not possible in a triangle either.
No, we can't have negative 10 degrees in
So
a
I
triangle.
think what we just decided is that example 1A gives us one triangle.
One triangle, because we tried to find the second one.
And it didn't work. It
It
gave us
didn't
an angle.
exist. So that's okay.
That's all right.
All right, so we can still have one triangle even with angle side side.
Yes, we can.
All right.
Okay. But other things can happen. This is why it's called the ambiguous case.
Oh, good.
Okay. So, again, let's try to draw a triangle. This time we're going to start with the angle of 125. Should probably draw that like this. So here's 125 degrees.
That's capital R. So little r is opposite side of that 6.
Okay.
And S is going to have to be on one side or the other. You get to pick.
I'll
and
pick
then
that one.
Little s will be 14.
Okay.
We probably need another letter, so
I'll pick T.
T comes after R and S.
RST. Okay, so to solve this triangle, what would we be finding first?
Well, we probably need to go for angle S because we got sine of 125 over 6 is going to equal sine of S over 14.
Okay, so we're going to solve that. We're going to get the
Multiply
sine
both
of
sides
S.
by 14.
Yep.
The problem, did you write it down? The sine of,
Can you
well,
find it on
I
there?
got 14 sine of, I got the actual number here.
Okay.
Hold the phone.
He's got the number.
When you multiply 14 times sine of 125 over 6 to actually do the law of sines, which is, that's the algebra there to do that, you end up with 1.911 something. And then to solve this, how are we going to do this?
Well, we're looking for an angle, so aren't we going to do a sine inverse?
Yes, so we do sine inverse of 1.911 dot dot dot, all those decimal places, but your calculator comes out with an error message. And why would that be?
It's a sine curve.
Sines can't go above 1 or negative 1, can it?
Nope.
So when we had this point down here where it said sine of s is 1.911, you know
Error.
right away it's not going to work.
It's never going to work there.
And if you can't find angle s because it doesn't work, what does that mean?
That means you can't find anything, and there is no triangle at all.
So,
Okay.
in other words, the one you drew really doesn't exist.
It really
does
doesn't exist.
Basically, it comes down to 6 is almost really too short.
A little bit. So that's a preview for that more to come later.
Yes.
Okay. Last example. Go ahead
All
and
right.
give that one a try.
Let's go ahead and draw this wonderful triangle. We got A's and B's. And again, we got to come up with another letter. So we'll call angle A 38 degrees. And we get in this habit of drawing them always the same way. Is that okay?
It seems to make more sense, because then you can look and see, does that top thing flip back and forth?
So A is 38, little a is 14.
Yep.
And then B was going to go down here, and then that makes little b 21. And this kind of, again, looks like our angle side-side picture that we
Yep.
had earlier. So,
I'm going to pick C for the top.
so good choice. So we're going to go sine of 38 degrees over 14 equals
Sine of B.
sine of B
Over 21.
over 21. And we go through this whole process. And what'd you get for B?
I don't know, you took my paper.
I did take your paper. I got 67.442
.42442.
degrees. Is that okay?
That's great.
And so how do we find angle
C.
So, but right now we know there's one triangle, yes?
We do, because we got an
We're
answer for
guaranteed
B.
one because we got an angle and we can always
We
find
are.
the rest of them. So,
We are. In fact, if you want to look ahead at your example 2, let's go ahead and finish finding the rest of that, because we're going to have to, on example 2 anyway, solve the triangle in example 1C.
and those of you that play school really well, we just did an example where there was one triangle, then we did one where there's no triangle. So, guess what? All right.
This one's 2?
I think they know what's
They
coming.
know what's coming. You
So-
should probably pick up your pencil now, though.
We got B at 67.442. To get angle C, we just do 180
Minus the 38 that we know, and minus B.
And that came out to be approximately
74.558 degrees. Our board is lovely.
Board sucks. Okay. But it's nice and pretty. We got a new projector. Okay. We've got angle A, we got angle B, we got angle C. Now we need to go ahead and finish and find
Side C.
side C.
Okay, so we're going to go back to our original proportion. The sine of 38 over 14 is going to equal the sine of big C
which
over little c.
we stored in our calculator,
We
hopefully.
did, and hopefully you did too.
Over little c, and this is what we're solving for.
Yep,
And again, you've done this before, so little c is approximately.
21.919.
Okay. Easy enough?
And that would make sense.
But that guarantees us how many triangles?
One.
One. But are we done?
We're not done. We got to
Once-
see.
Once
if-
we got angle side, we need to check to see if a second triangle is possible.
Exactly. And always, always go back to the first angle you found. You found angle B. If this side went the other way and the 14 was really there, then these two angles are congruent. So the other angle B is on the left side.
That's where we just subtract
of that
180
linear
minus
pair.
that first b, correct?
Correct.
All right, so let's go to the next page and do that. How's
Okay, I'm
that?
going to let you write.
So we're really now trying to solve for this triangle. Is that right?
That's great. Let's go ahead and redraw that triangle,
So
actually.
yeah, we'll go ahead and do that. So our little triangle here was kind of like this,
It was exactly
and
like that.
and A was here, and B was now here, and C was here, and 38, if it's possible, by the way.
Right? And
Little
CB
b
would
was
be
21,
14.
and we figured out that. Well, we don't have a new C yet, do we?
We don't.
So on this side, we had figured out that this was what again?
It was
67.
67.442. So that is a
So-
linear pair with the angle ABC that we are actually looking for. So we're just going to go 180 minus 67.442, the one we found. And 180
Which is?
minus 67.442 is 112.558. Now, here's where we ran into the problem on the other problem, okay? On example A, that was.
Is there room
Okay.
for a third angle?
I
That's the
don't know.
question.
Let's find out. So if we're going to go figuring out the other angle C, we're going to go angle C is 180
C is equal to 180
minus the 38 minus the new B, which is 112.558. And when we do that, we actually get 29.442. So there could be a little tiny acute angle up there. And now we could have two triangles. It does work.
Yes. So for the purpose of this question, when it said how many triangles exist,
The answer's 2.
the answer's 2.
We just found 2 of them.
But we're already on our way to almost finishing example 2 because we have now,
We are.
we already solved the first triangle that existed here. We had angle B, we had angle C, we had side C. Those are our 3 missing pieces.
Yep.
And now we've got angle
B,
C.
you should label that.
We've got angle C here. This is our new angle B, right?
Yep.
So our new angle C.
Now we
and
just
so
need our new side C.
That's it, and we're done.
Okay.
So we're going to go sine of 38 over 14 equals sine of angle C, which was our 29.442 angle, divided by little c, which is what we're solving for.
And when you do the arithmetic there, you're going to get 11.178.
178?
Yep. Which makes sense. Remember, in geometry, there was a theorem that said that the smallest side is going to be across from the smallest angle.
So in this
and the
triangle-
biggest side will be across from the biggest angle.
Our smallest angle was 29.442, and it was opposite 11.178.
Correct. And if angle B was the obtuse angle, it's across from the 21. But,
Over here, our smallest angle was B,
which is acute.
and so its smallest side was 21, which makes sense because C was a little bit longer than 21.919.
Okay, so when we're looking for a second triangle, we're going to imagine what did we go find first, and then we're going to go back and do 180 minus that and see if we can create another triangle. Now, some of you are going, oh my gosh, this is so much work and they only give us a little bit of room. Why
Aren't you glad they're not here to listen to that?
There's got to be a shortcut, right? What's the shortcut? Okay, some of you will be fine just trying to solve it every single time.
This is for
Just
you
try
formula
to solve it.
memorizers out there.
Okay, but if you really want to know, is there a shortcut here? Of course there is. When we look at the answer that we got that had no triangle, what did we know?
Well, I
We
knew
knew
there
an
was an
angle that's
obtuse angle,
obtuse. Mm-hmm.
and I knew the opposite side was actually shorter than the other side that I was given. That's what I did know.
Actually was. These were the exact values. It was 125, 6, and 14.
Which is why there's no triangle, because it's too tiny to reach the other side.
Right? The biggest side has to be across from the biggest angle.
Oh,
and
you
if the
can't
6
have
is
an
smaller.
angle bigger than 125 in a triangle, can you?
No. So if the only two sides I know are 14 and 16, doesn't the 14 have to be across from the 125?
Or
something
bigger.
even bigger.
Yes.
Okay? So that's a shortcut. Okay? So if you want to remember that, you can. You're talking about the small side across from an obtuse angle, and just know that's bad. You like my bad?
Actually, they'll probably be happy, because once they realize there's no triangle, there's no more work to do. You're done.
Right. Okay, so now let's go back again and look at example 1. On letter A, we ended up with one triangle.
Okay,
And
so
the
why
pieces
did
that
we end up with one?
Okay, well, we had a 56-degree angle,
Okay, which was acute this time instead of obtuse.
and across from it, we had a 30 for a length of our side.
Okay.
And the other one was a 26. Now, this is very clearly not drawn to scale. However, what do you notice about 30?
It's bigger than 26.
It's bigger than the 26. So when we're talking, if you would hold this, please. When we're talking about the exploration we did where we had this, and then we flipped our ruler the other way, there is no flipping the other way because 30 will come past the bottom. And I can't move the bottom because that changes an angle of 56.
Right.
Okay? So again, that's going to create
So
one triangle.
when we have an acute angle here,
Yes?
and then the side opposite here is longer than the side we were given,
Yes.
we can't have that second triangle.
Correct.
Okay.
Okay, that leads us right into the third scenario with two triangles. And if we just switch the two sides that we know, on the last example, I believe this was 29 degrees, is that right? No, it was 38.
It was 38 degrees.
That was close.
But you know, that's close to 29.
I can't even erase it. 38 and 29 are
This is the
close.
part we
Okay, I'm going
should
to
edit
remember
out,
that for my
But
birthday.
it's more humorous to leave it in.
Okay, 38 degrees is close to 29. Ask Mrs. Eubler about that. Okay.
You're not 38.
She's not 29 either. Okay, so 38 degrees is here. What were the two sides we knew?
The side opposite that was 14.
Okay.
And then the given side to the left was 21.
Okay,
Which is exactly opposite of what you just said. So,
I was close. All right, so
no,
again,
I mean for the one triangle.
right. So if we have an acute angle, and across from it is the shorter of the two sides, then there's an opportunity for that 14 to flip the other direction and create two triangles. Okay?
Okay,
So,
so
as far as remembering, if you like memorizing rules, here's the one and only one that I remember. I remember when this is going to happen. If the little side is across from a little angle and the bigger side is in the middle of them, then you could have two triangles. You like my little mnemonic? I could do it for all of them. If the little side is across from an acute or obtuse angle and the bigger side is on the other one.
I like that.
You like that one?
Yeah.
Okay, and on the middle here, if the bigger side is across from an acute angle and the little side's in the middle, then I'm going to have one. Okay?
Formula memorizers, have fun. For the rest of us that just want to do it, just go ahead and look for the second triangle every
Yep,
time.
every time.
And if it turns out it doesn't work, then you just say, oh, it's only one.
Yep.
And if it turns out it works, you were already going there anyway, so it's no big deal.
And the good part about that is you won't miss it. If you always look for it, you won't miss it.
It's like being a pessimist. You're either right and tell me told you so, or you're wrong and you're pleasantly surprised.
Nice.
Okay, I think that'll do it for the rest of our day.
That's enough. We will see you in class.
Have a good one.